Let's say you work at a hospital and a doctor asks you to provide medication for a patient. And the doctor tells you that a patient needs 300 milligrams of acetaminophen. And you go to the stock room, you grab the bottle of stock medication and you read the label. But the label says something different than what the doctor ordered. The label says that each tablet within the bottle contains 200 milligrams of acetaminophen. What do you do? That's what we're going to learn in this video, the fourth, I think, in this series. We are going to learn about this equation, D over H times Q, where D is the doctor's order. This is always going to be a value that is equivalent to a mass or a weight of something. So if we're in the metric system, which is going to be the most common, this is going to be something in grams, milligrams, micrograms, right? Some variant of grams. And in fact, those three units that I just mentioned are going to be the three most common units that you see. H is the amount of medication that you have on hand per dose according to the bottle. So in our previous example, the one that we're going to work on here in just a minute, the dose on hand, the bottle's label, said that there were 200 milligrams per tablet. H is always going to be a unit in mass as well. So we're going to be looking in the metric system for some variation on grams, milligrams, or micrograms. In our example, H is going to be the number of milligrams. This leads us to Q, which is sometimes the most difficult variable to understand. Q is the quantity of medicine that you have to consume or inject or somehow get in your body in order to get one on-hand dose. This is always going to be a volume of liquid or a number of tablets. So let's go back up to our example. The patient needs 300 milligrams of acetaminophen, but the bottle says that each tablet has 200 milligrams. Now, this is a cute picture, but it's not very easy to really understand the word problems that you're going to be seeing as you practice this without actually converting this to a word problem. So we've converted this. The doctor orders 300 milligrams of acetaminophen for a patient. The stock bottle reads 200 milligrams per tablet. This is where our understanding of the variables of our equation comes in handy. We are going to, before anything else, isolate our variables. The first thing we need to find is D. D, remember, is what the doctor ordered, and it's going to be in a unit of mass. So in this case, we look for buzzwords or keywords or key phrases such as the doctor orders or the patient needs. And then we look for the mass of medication that the doctor requested. In this case, it's 300 milligrams. So our D, our variable D, is 300 milligrams. Now we're moving on to H. H, remember, is the mass or the weight per dose of the medication that you have on hand. We're going to go straight to the label of the bottle for this information. The stock bottle reads 200 milligrams per tablet. Remember that H is always in mass. All right, that's what we're measuring, is the mass of this medication. And so we're looking here in the metric system for some variation of grams. What we get is 200 milligrams per tablet. And so what we're going to find is that everything before what this slash or the word per is going to be our H. In this case, it is 200 milligrams. This leaves us with Q. Remember that Q is always a volume. It's always an amount. It's an amount of medicine that you have to consume in order to consume our dose on hand. So it's always going to be a volume of liquid or a number of tablets. In this case, what we have here is this slash and then the word tablet. We can rewrite this as per tablet. Or if you wanted to get even more technical, we could rewrite it as per 1 tablet. And so our Q is equal to 1 tablet, because you have to consume 1 tablet in order to have consumed 200 milligrams of medication. Our next step is to plug it in. So I'm actually going to bring up our numbers here so we can see them. And we're going to replace our variables in our equation with the variables that we just isolated. So D is not D. D is 300 milligrams. H is not H. H is 200 milligrams. And Q is not Q, of course. Q is 1 tablet, which I am here going to abbreviate as tab just for the sake of space. This equation will tell us how many tablets we're supposed to give at this time. Let's do the math here. 300 milligrams over 200 milligrams. Milligrams over milligrams cancels out. And we can divide each of these numbers by 100 in order to simplify this fraction. 300 divided by 100 is 3. 200 divided by 200 is 2. And so we're left with 3 over 2 times 1 tablet. 3 over 2 times 1 tablet, that is 3 halves of a tablet, or 1 1/2 of a tablet. And this is always going to be per dose. But let's say something kind of weird happens. Let's say that the doctor orders 200 micrograms of another medication. We'll call it medication R. The bottle that you have reads 0.4 or 4/10 of a milligram per tablet. The question is, how many tablets should the nurse give per dose? So D is what the doctor ordered. The doctor ordered 200 micrograms of a medication. H is still the mass of medicine per dose on hand. The bottle reads 0.4 or 4/10 of a milligram per tablet. We always stop with the first unit, right? So we're going to write 4/10 of a milligram. Q is still the number of tablets in this case, because we are in tablets, that we need to consume in order to have consumed 4/10 of a milligram. And in that, we see that it's per tablet again. So we know that Q is for every 1 tablet. Here's the problem. D is 200 micrograms. H is 4/10 of a milligram. Milligrams are not equal to micrograms. So if we were to plug this into our D over H times Q, we would have 2 different units in that fraction, and we wouldn't be able to cancel our units. So we're going to move on to what I like to call step 1.5, which is convert. We need to convert one of these, be it 200 micrograms to milligrams, or we need to convert 4/10 of a milligram to micrograms. So let's do that. I've made an outline here. We know that 4/10 of a milligram needs to become micrograms, but we don't know how many micrograms that is. However, we do have our equivalent, which is that 1 milligram is equal to 1,000 micrograms. Let's do some math. Let's do some dimensional analysis. You guys know that I love this, right? We start, of course, with our given over 1, 0.4 or 4/10 of a milligram over 1. We're on a roll, right? Now again, we always have to ask ourselves, if milligrams is here, what must go here? the same unit. It's always the same unit. We only have in our equivalent one phrase that involves milligrams, and so we're going to put 1 milligram there on the bottom. And that leaves us with 1,000 micrograms to go on top. Now we can ask ourselves, if we were to do this math, we would be left with micrograms as our final unit. And that is in fact what we're looking for. So we know that we don't need to add any more fractions to multiply. We can just write in our equal sign and begin canceling units. Milligrams on top and milligrams on bottom. We can cancel those out. That leaves us with 4/10 times 1,000 micrograms over 1 times 1. And because anything over 1 is itself, I'm not even going to bother writing over 1. I'm just going to write what 4/10 times 1,000 micrograms is. We see that the answer is 400 micrograms. And so we can fill that in here. Now what we need to do is go back to step 1. If we come back to step 1, we can rewrite H with our new information. So H is not 4/10 of a milligram. H is 400 micrograms. Now our units match. And so we can move on to step 2. Plug it in. D is not D. D is 200 micrograms. H is not H. H is 400 micrograms. And Q is not Q. Q is 1 tablet, which again, I'm going to abbreviate as tab here for the sake of space. We can do our math now. Micrograms over micrograms cancels out. 200 over 400. We can divide each of these by 200 to simplify. And we are left with 1 over 2 times 1 tablet. Our answer is 1/2 of a tablet per dose. Now that's pretty easy. I'm sure you've noticed that every time we've dealt with tablets, Q has always been 1. That's because it would be kind of ridiculous to package pills and to say you have to take more than 1 pill or like a pill and a half or even half a pill to get a whole dose. It's very counterintuitive. It would be very irritating. And so the way that medicines are packaged, they're packaged to make things as smooth as possible. But here's the thing, not all medicines are tablets. Let's say that a doctor ordered 500 milligrams of medicine A for a patient. The medication is bottled at 25 hundredths of a gram per every 5 milliliters. How many milliliters are you going to give per dose? Now this is a trick. The first thing we have to do is be able to conceptualize what this even means. And so I have a fun, dorky example. Let's say it's a cold day outside and you want some hot cocoa. So you're going to make some hot cocoa in your favorite mug. The first thing you're going to do, and please, I'm using these numbers from our last example. I do not expect you to use this little water in making hot chocolate. Let's say you pour in 5 milliliters of water. For your hot chocolate. What else do you put in? The hot cocoa powder, right? In this case, it's going to be orange because I don't have the color brown. So you're going to take your packet of whatever brand of hot cocoa you prefer. And the hot cocoa powder is going to fall into the mug, right? And eventually, it's just going to kind of be lumps on the surface of the water. Let's say, just for kicks, that each hot cocoa packet contains 25 hundredths of a gram of hot cocoa powder. Now you have added both of these ingredients to your mug. And what we can do now is stir. So you're going to take your spoon or your stirring stick or whatever utensil it is that you would like to use, and you're going to stir this together. And what will the result be? A homogeneous mixture, or a completely stirred mixture of hot cocoa, right? Where you can't see pockets of water or anything. And then maybe, you add some marshmallows and some whipped cream to your truly abysmally small amount of hot chocolate. But what if you drank this entire cup of hot chocolate? What if you drank 5 milliliters of hot cocoa? How much powder would you have consumed? That much, right? Let's go back to our example. Our medication is packaged at 25 hundredths of a gram per 5 milliliters. If you drink all 5 milliliters of your hot cocoa, you're going to consume 25 hundredths of a gram of hot cocoa powder. In the same vein, if you consume 5 milliliters of this suspension, we call it a suspension when we mix medicine into a fluid. If you drink 5 milliliters of it, you're going to consume 25 hundredths of a gram of medication. So now that we know what that means, we can move on to step 1. D is equal to what? The doctor ordered 500 milligrams. What about H? You have on hand 25 hundredths of a gram for every 5 milliliters. H is always a mass, meaning some variant of grams. So we're going to stop after we hit grams. That leaves us with Q. Now our Q in the past has just been one tablet each time. But here we see that our mass of medicine is only possible. You can only get that much medicine if you consume 5 milliliters, if you consume this quantity of medicine. And so our Q is 5 milliliters. Now we can move on to step 1.5, which is to ask ourselves, do we need to convert anything here? We are left with D being 500 milligrams and H being 25 hundredths of a gram. Milligrams does not equal grams. So we do need to convert. And in fact, we're going to do the same thing we did last time. We're going to convert the big unit to the smaller unit. I've written this out here. 25 hundredths of a gram is equal to how many milligrams? We have our equivalent, which is that 1 gram is equal to 1,000 milligrams. And now we can do our dimensional analysis. We always take what we're given, 25 hundredths of a gram, and we put it over 1. Now it's time for that age-old question, right? If this unit is here, what unit must go there? The answer is always the same unit, right? It's always going to be the same, so the answer is grams. In our equivalent, we only have one phrase that has anything to do with grams, and so we're going to put 1 gram on the bottom, leaving us with 1,000 milligrams on the top. If we were to finish now and do the math, our final unit would be in milligrams. And that's exactly where we want to be. So we know that we don't have to add any more fractions. We can just add the equal sign and cancel units. Grams are on top and grams are on the bottom, so we can get rid of those. And we're left with 25 hundredths times 1,000 milligrams over 1 times 1. Anything over 1 is itself, so I'm not going to bother writing it. I'm just going to write what 25 hundredths times 1,000 milligrams is. And in fact, we find that that is 250 milligrams. So we're going to go back to step 1. But instead of having 25 hundredths of a gram, we've changed our H to 250 milligrams. Finally, we can move on to step 2 and plug it in. D is not D. Let's go back here. D is 500 milligrams. H is not H. H is 250 milligrams. And Q is not Q. Q is 5 milliliters. So we're left with this question, with this equation. Milligrams over milligrams, they get canceled. 500 over 250, we can divide each of these by 250 in order to simplify. 500 divided by 250 is 2. 250 divided by 250 is 1. Anything over 1 is itself. And so we are left with 2 times 5 milliliters. And our answer is 10 milliliters per dose. And with that, you should now be able to convert between a doctor's orders and the medicine you have on hand.